Look at these two surfaces. On the left, intricately carved wood, organic, full of knots, shaped by lived time. On the right, a uniform wireframe grid. They meet at a clean seam. That seam represents the exact boundary between biological cognition and machine processing. When professional knowledge workers encounter friction using artificial intelligence, the prevailing industry assumption is that the fix lies in engineering. We assume seamless integration will inevitably follow lower latency, cleaner interfaces, and larger parameter counts. This diagram illustrates that expectation: a clean, frictionless pipeline from human input to AI processing to a neat task output. But that pipeline is an illusion. Real integration happens in the collision between human and machine. The Japanese word for this collision is sowagi. It translates to a structural disturbance, a deep disquiet. The fatigue, friction, and disorientation you feel when relying heavily on an AI system is sowagi. It is a measurable, physical symptom of interacting with an intelligence built on completely different principles than your own. That friction is not a bug in the code waiting to be patched. It is the inevitable symptom of dissonance between architectures built on irreconcilable principles of cognition. The confusion between these architectures begins with a single borrowed word: attention. We took a biological term, handed it to software engineers, and assumed the mechanisms were identical. This animation shows how a machine actually processes information. In a transformer model, attention computes co-relevance scores across a static corpus of text. It is a flat mathematical sorting operation based entirely on proximity and probability. Now watch what happens in biological cognition. Human attention operates through existential selection. An organism automatically separates the world into a bright foreground and a dark background based on what matters for its survival. To understand the machine side, we look to the mathematician Claude Shannon. He gave us the foundational concept of information entropy. Shannon entropy defines information strictly as the reduction of uncertainty, pure statistical surprise. By design, this metric is deliberately stripped of meaning, real-world consequences, or stakes. Contrast that with the cyberneticist Donald Mackay, who argued for structural information. For biological beings, information is not about surprise. It is the specific selective function that changes an organism's preparedness to act. Because we share the word attention, we falsely assume machines are preparing to act the way we do. They are not. Transformers produce statistical salience, but with absolutely no life behind the math to validate whether those guesses actually matter. Biological cognition draws its specific power not from limitless capacity, but from severe constraints. These limits are what allow us to anticipate the future. Through our senses, we encounter roughly 11 million bits of data per second, but we actively discard almost all of it, funneling it down to about 40 points of conscious awareness. That active discard is not a defect of human memory. It is a strict prerequisite for coherent attention. By throwing out the noise, we construct a stable, consequential background. Without that background, a specific anomaly cannot stand out. The second constraint is valence. The things that survive exformation are weighted by experience. A trained eye ignores 90% of a problem because previous failures taught exactly what details carry a real cost. Salience is earned through consequence. The third constraint is affordance and habitus. Years of physical and historical reality sediment into the body of a professional, disposing them to recognize action possibilities before they even formulate a conscious thought. AI developers argue that modern systems are also highly constrained. They point to architectural algorithms and reinforcement learning from human feedback as proof that AI can be directed. Those constraints are powerful, but they are externally engineered. They are bolted onto the system from the outside. Biological enabling constraints are sedimented from within, grown out of lived consequences and actual risk. Added constraint is not earned constraint. A cage is not a spine. An artificial system without a physical life to protect can never possess an apparatus built entirely on the consequences of failure. We can map the specific limits of human and machine capabilities using the existential orthogonality principle. This scatter chart maps the difference. The horizontal x-axis represents computational capability. The vertical y-axis represents existential capacity. the ability to bear consequences. Large language models stretch endlessly right in raw compute, but stay flat on the floor. Biological organisms sit high. Scaling compute does nothing to generate agency. The dividing line that matters is not carbon versus silicon. The line separates systems that anticipate a future they have to live in and systems that do not. Because current AI cannot bear consequences, it cannot care. In any integration between the two, the human is the only agent capable of supplying the existential stakes. To act effectively, a human must project a coherent internal forward model of the world. This model takes the shape of a causal bubble. Resolution dictates the level of causal detail a person processes. Horizon marks the furthest temporal reach of planning. When an AI generates text that exceeds your resolution or overshoots your horizon, it breaks the model. More detail is not synonymous with more help. Unframed, dense information delivered at the wrong scale actively destroys a professional's causal coherence. The data delivered outside your causal bubble might be technically accurate, but it is existentially useless. It strips away operational empowerment and replaces it directly with swaggy. Delivering useless data is frustrating, but the deeper issue is the constitution problem. AI outputs function as direct edits to the forward model you use to think. This sequence demonstrates the stealth of cognitive diskilling. When you outsource your initial thinking, fluent machine tokens begin to silently override your own organic guessing. The atrophy follows a strict timeline. At time 1, you are in an active state of cognition. At time 2, the AI begins interfering, offering highly plausible hypothesis-shaped answers. By time 3, you reach full dependency, relying on the machine to generate the structure of your thoughts. The mechanism is quiet. By letting the system generate the hypothesis, you permanently lose the opportunity to build the very competence required to evaluate if the machine's guess is right. Habitual reliance on an AI oracle inflicts real cognitive harm. It systematically substitutes pattern-weighted plausibility for experience-weighted judgment. We can halt this atrophy by moving to the second student model. Drawing from the Oxford tutorial tradition, you do not learn by receiving answers from an oracle. You learn by sparring with a partner who forces you to defend your own thinking. The rule for integration is strict. The human supplies the anticipatory model and the direction. The AI sits exclusively inside the user's causal bubble, acting as a generator of computational friction. The status quo interface, the standard chat window, is optimized entirely for raw information transfer. It leaves your internal forward model completely unprotected from data dumping. This wireframe compares the standard text wall with the anticipatory agent framework interface. Before the AI generates anything, the user fills out a bubble statement. This explicit step forces the professional to lock in their operative assumptions and hypotheses first. Once the AI responds, the surprise register column isolates the discrepancies. It frames the machine's output strictly as material to update your hypothesis, rather than presenting it as an absolute finalized answer. This structural alignment achieves harmony through structural difference. The human's anticipatory nature and the AI's reactive computing power interlock, becoming mutually generative instead of destructive. The final goal of this framework is cognitive sovereignty. That is the core capacity of a human agent to maintain, revise, and act upon their own forward model without illegitimate interference. To protect it, we must change the core ethical standard of AI design. We have to stop asking, did the system obey the prompt, and start asking, did this interface constitute a more capable human agent? When we allow statistical mimicry to mediate our attention, we outsource our ability to recognize what matters. We narrow the scope of the world we are capable of modeling and acting upon. Machines gather, weigh, and synthesize, but 3 actions remain entirely human. We abduce, we interpret, we decide. Attention, in the machine sense, is not all you need. The capacity to bear the cost of being wrong is what makes the mind sovereign, and it is ours to defend.